Welcome back to Aisha.Academy, and in today's video we're going to be going through useful differentiation for gradients, tangents and normals. So first but not least, if we have a graph and let's say we've got a curve, so let's say you've got a point on this curve and you've got the line that's intersecting it, so we call that our tangent, because remember tangent is the line that touches the curve, right? So the gradient of a tangent for the curve, okay, is the same as the gradient, the dy by dx of the curve. This is really important to remember. Whereas let's say we've got a line going perpendicular, we call that our normal. So the gradient of the normal is the negative reciprocal of the gradient of the curve, aka minus 1 divided by dy by dx of the curve. This is very important to remember because a lot of times people get confused with the tangents of circles, which is the negative reciprocal, but here is not the case. So let's say if we've got a curve, right, and we have that bottom part of that curve, so the part where it eventually curves over, we call that our stationary point, right? Because it's not really on the actual curve, it's just the stationary point. So our stationary point is when dy by dx is equal to 0. So if we were to differentiate our dy by dx, we end up with a term known as d2y over dx squared. So this is how we write it out. And there's two things you need to be familiar with. If d2y over dx squared is greater than 0, we call this our minimum point. So if it's greater than, it's minimum. It's basically opposites. That's how I remember it. Whereas if your d2y over dx squared is less than 0, we call that our maximum point. Okay, and this is basically your turning point of a curve graph. The next thing I want to touch on before we jump into questions is our increasing and decreasing functions. So again, this is a graph. So let's say if we have an equation of a graph where it's just y is equal to f of x. So it's just any graph, essentially. But when it's to do with a curved graph like this quadratic curve here, there's two things I want you to notice. The first thing is, if we are to work out the derivative of the function, so remember it's f dash and then your brackets x, as I mentioned in the basic differentiation video. If your derivative of the function is less than or equal to 0, this is for a function to be decreasing, okay? Whereas if your derivative of f of x is greater than 0, it's going to be the opposite, increasing functions. And the reason why I drew a line over the x-axis is because how I remember it is your decreasing functions are kind of below the x-axis. Your increasing functions are above the x-axis. So now we're going to put all that knowledge into some practice questions. So example 1. So exam question is giving us an equation and it basically wants us to work out the gradient of the tangent where x is equal to 5. So the first thing we're going to do is work out the derivative, because remember we mentioned in the basic differentiation video that the derivative is equivalent to the gradient. And so if we were to differentiate that equation, we would end up with 3 minus x. So when x is equal to 5, we are now going to substitute x is equal to 5 into this, because as I mentioned earlier, the gradient of a tangent is the same equation for the gradient of the curve. So 3 minus 5 would leave you with an answer of minus 2. And that's literally all you need to do. So let's say part B, it now says find the gradient of the normal at the same point x is equal to 5. Remember, for the gradient of the normal, you need to do minus 1 divided by the dy by dx of the curve. So we're going to do minus 1 divided by minus 2, because we already know the actual value when x is equal to 5. And working this out will leave you with an answer of a half. Part 2 now says find the equation of the normal. So the first thing you're going to do is work out the actual y value for when x is equal to 5. So you're going to substitute x is equal to 5 into the initial equation at the beginning. So then that's going to be y is equal to 3 times 5 minus a half 5 squared, or half multiplied by 5 squared. And basically, if you were to put this in your calculator, or if you were to manually work this out, you should be left with an answer of y being equal to 5 over 2, also known as 2.5. So now we worked out our y value. When it comes to the equation of a straight line, because we know normals are straight lines, right? This is your go-to equation. You're used to seeing y equals mx plus c. But another format you need to be familiar with, especially at A level, is y minus y1, y1 being the y coordinate of that point. And then you've got your m bracket x minus the x coordinate of that point. So now we know the equation, we're going to substitute in the values. So it's going to be y minus the 5 over 2, because we know that's the y value of that point when x is equal to 5. And that's going to be equal to our gradient of our normal, which we worked out was a half. And then multiplied by x minus the x value at that point, which we know is 5. If you were now to simplify this and to rearrange this, you would end up with an answer of y actually being equal to just a half x, because everything else would cancel out. And that is your final answer. So we're going to go into example 2. So this example question just wants us to work out the dy by dx and the d2y by dx squared. So the dy by dx, if we were to differentiate using our knowledge of basic differentiation, I'll put the link in above, would leave you with an answer of 9x squared plus 12x minus 5. So the link above is to refresh your memory on basic differentiation. d2y over dx squared is just differentiating the dy by dx, which would leave you with an answer of 18x plus 12. So that's it for that. And then in terms of part B, it's now saying evaluate, so basically work out your dy by dx and your d2y by dx squared when x is equal to a third. So we're going to substitute x is equal to a third into our dy by dx. So that's going to be 9 multiplied by a third squared plus 12 multiplied by a third minus 5. So putting that into your calculator, working out manually would give you an answer of 0. Then if we were to work out the d2y by dx squared, you would end up with 18 multiplied by a third plus 12. And that would leave you with an answer of 18. So the key thing here is because our d2y over dx squared, so this is answering part II, is greater than 0, because it's 18, right? This is therefore going to tell us that when x is equal to a third, it is going to be a minimum point. And the last example is, first of all, it wants us to work out the derivative of the function. So f dash x, should be a dash there. So f dash x should be equal to 3x squared plus 2x minus 5. And then it says now solve the equation. So solving it, we can put it into brackets. So we're factorizing the quadratic. This would leave us with, in one bracket, 3x plus 5. And in the other bracket, we would end up with x minus 1 being equal to 0. But if we were to now actually solve it, equal to 0. So if we were to now solve it, x would be equal to minus 5 over 3. And x would be equal to 1, because we make each bracket equal to 0. So now where it says hence or otherwise find the values of x for when f of x is a decreasing function, remember, if it's a decreasing function, it's where the derivative is less than or equal to 0. And so we can see that below the x-axis is like kind of that sandwich part. So you're going to write as a sandwich inequality for your values where x is a decreasing function. So you'll write it as minus 5 over 3 is less than x, which is less than 1. And that's all you need to do. So yeah, I hope that was useful, guys, and stay tuned for more content. Thanks for watching.